Okay, so now that we have the pump all set up, the next thing we need to do is create a circuit for the lights. Now this is going to be really similar to the circuit we used for the pump because it's going to be the exact same thing with the relay and the power source, but we have to do a little bit of soldering on the lights to make them all work. So let's get started. Okay, so the way these light strips work is they come in segments, so you're able to cut as long or as short a segment of lights you need, which the segments are shown by these little lines with wires, scissors on them. So you're able to cut along that line and take a segment without damaging the rest of the lights. So measure out how much lights you need and then cut a segment of the according length. I'm using a rather short segment here just for demonstration purposes. So if you look at the end, either end of it, there's two copper circles, one with a positive sign, one with a negative sign. So this is where you can put in your wires. So the positive one obviously is the positive end, so we need a positive charge going in there, and a negative one is where we want our negative wire. And these wires are rated for, or these lights rather, are rated for 12 volts DC. I have a 9 volt DC battery here, and it seems to work fine. So if you have a 12 volt DC power source, use that. But I'm just going to be using this because it works. So all I'm doing is testing the lights are working by putting the two ends of the positive and negative ends of the wire onto the positive and negative ends of the light strip, and we should see some lights. The light strip is not damaged, and it works, which means the light strip isn't damaged. And the reason it's kind of flashy and weak is because the connection I made by just holding the wire onto the two terminals, onto the two copper circles, was rather weak. So to solve that, what we're going to be doing is soldering wires onto each of them. So soldering one wire onto the positive copper circle and one wire onto the negative copper circle, and that way we're able to easier use this and plug it into our circuit. So this is just some wire I have, which is thin enough to plug into a breadboard, and is still thick enough to work with. So I'm just gonna be cutting 2-inch lengths of this wire. The length doesn't really matter with the wire clippers, and then I'm using the wire strippers to strip off the ends of the wire. And this is because one end of the wire we want to solder to the light strip, and the other end of the wire we want to be able to put in our breadboard so we can make circuits with this. So just strip off both ends, so it looks like that, for both of the two wires that we're going to be soldering. So just a note on soldering is, it is dangerous. The soldering iron gets to 300 degrees Celsius, and we're really melting metal here, so just treat it with respect. Don't have it turned on if you're not there. Make sure it's in its holder if you're doing something else while you're at your station, and just try not to burn yourself because it's really not a good idea. So just treat this with respect and be safe. So I'm using lead-free solder with flux in it, and flux just is better because it helps it stick to things. And I have rather thin solder, which is good because it allows it to melt faster. So make sure it's lead-free, it has flux in it, and that it's thin. So all I'm doing here is I'm what's called tinning the wire. And that means I'm getting a little bit of solder onto the ends of the wire so that we're able to easier stick the wire to the copper terminal on the light strip. So the way I'm doing this is I'm using the soldering iron in my right hand to heat up the wire in my left hand, which melts the solder, and then the solder will solidify onto the wire. So now we have a nice coating of solder on this wire, and if I'm able to focus here, you might even be able to see it. So it's tough to see, but on the end of the wire there, you can see there's a little bit of solder, and that's also, it means there's a coating of solder on the wire all the way around, and that's what we want, because it means we're better able to stick to the copper terminal on the light strip. So now we need to do the same thing that we just did on the wire to the little copper circle. So we need to tin it. So this is, I'm heating up the copper circle and then melting the solder onto the copper circle so that there's a little droplet of solder on the copper circle, which will allow us to connect the wire to it and complete the solder. So that one was easier. Nice. And see if I can focus in. Now you can see on the left hand, the negative terminal, there's a little droplet of solder, which is now solidified. And that's what we want here. So, sorry for the jump, but when I first recorded it, it was not in focus, so I have to do it again. But all we're doing here is I'm taking the wire which has been tinned and placing it on top of the tinned terminal on the light strip, and then I'm just melting the solder on both of them so that they're able to fuse and join, and then when the solder melts, it will create a nice firm connection. There we go. So let's see if you can see this. But yeah, a nice connection. So all I did is I put the tinned wire onto the tinned terminal, and then melted the solder with the soldering iron, and then fused the two together. So now we need to do the exact same thing, but with the other wire on the other copper terminal. So try and speed through this, but once again, we're just tinning the wire by using the soldering iron to heat up the wire, and then using the wire to melt the solder, so that we have a little bit of coating of solder on the wire. The same thing as before. You can see there's a little bit of solder on there. And then we need to do the same thing with the light drip. So on the other terminal this time, we can heat up the terminal to melt the wire, and we get a little droplet of solder on it, and then we can fuse the two. So an important note here is you want to make sure that the two wires, there's no metal touching, because obviously that would short out our circuit, and that's not anything we want. So don't overuse solder. Like, make sure you're using a conservative amount, so that I have a hand blocking here. Make sure you're using a conservative amount so that you're not accidentally shorting out the shorting out the circuit. So nice. So now we have our two ends soldered onto the wire, onto the light strip, like that. It doesn't have to be very pretty. All it has to do is hold to make a firm connection. So we can test our connection by taking our battery once again and connecting our battery to the ends of the two wires to make sure it works. And that's what we're going to do to test it. But before we do that, what we want to do is wrap the end of it, like wrap where we have exposed wires. We want to wrap that in electrical tape. For the same reason we wanted to wrap the exposed wires when we did the pump. It's a safety precaution, and it will make sure that the circuit doesn't short, and also it adds structural integrity to the solder. Because as you saw, there wasn't actually a lot of solder there, so it's possible that over months of wear and tear that solder could come undone. So all I've done here is I've wrapped it in electrical tape, which helps add structural integrity to the solder and make sure there's no exposed wires. It makes sure there's no short circuits happening. It's just a good thing to do. And now we're going to test it. So I just take the same battery as before, connect one end, the red end of the battery, to the positive end. And since we taped over the pictures, which showed us which end was which, all you need to do is go to the other end of the strip and check the picture there, and then you can just use the same one. So I'm just connecting these two wires. Obviously, I disconnected this from the battery because otherwise I'd give myself a shock, which I don't really want to do. So this is just testing. This is not going to be a firm hold. This is just to make sure that our solder was successful. And the reason this is going to be a firm hold is because these wires I have on the end of this battery kind of suck. So maybe we don't wrap them. I think I'm just going to touch the two together so that I can check if the solder actually worked. So hold that down. And here we go. So yeah, just touch the two, and you can see that the light still turns on because the solder was successful, and that means it's not short circuiting, and now we're able to actually create a circuit with that. So in order to create a circuit, we're going to need the same things as before. We're going to need the Raspberry Pi, we're going to need the relay board, and we're going to need a breadboard. And eventually we'll have all this in conjunction, so we'll have the pump setup we did in the last video with this setup, but for now I deconstructed the pump setup so that's easier to see. So the first thing I'm doing is I'm connecting the 5-volt pin on the Raspberry Pi to the positive rail on the breadboard, and doing the same thing to the ground pin, so the ground pin on the Raspberry Pi and connecting to the ground rail on the breadboard. And then I'm going to connect a GPIO output pin. Again, it doesn't matter which one, but use a different one than you used for the pump, because obviously we can't have the same pin controlling the pump and the lights. That wouldn't make sense. But first, what we need to do is connect the VCC pin on the relay to the positive rail on the breadboard, and then connect the ground pin on the relay to the ground pin on the breadboard. This will give power to the relay and allow it to work. And now I'm using the GPIO pin. So take a GPIO pin on the Raspberry Pi and connect that to an empty row on the breadboard. And then this time we used the input 1 for the pump, so we're going to be using input 2 for the lights. So that means we're going to have to be using the second relay. So for the pump we use the first relay, and for the lights we'll use the second relay. Cool. And now if you remember with this relay, the way you do it is you need a screwdriver to open up hold down the holes and make sure the wires stay in place. So I'm putting the positive end of the power source into the middle, which is the same thing we did last time. So Okay, or I'll throw my screwdriver. So put the positive end into the middle one and screw that in. Nice. And then we're going to be using the light strip, and make sure you have the positive wire. Again, check the other side of the light strip because we taped over, and put that into the normally open pin. Remember from last time, the normally open pin only has power flow through it when we activate the relay. So this means when we turn on the relay, we'll have power. When we activate the relay, we'll have power flow through the normally open pin, and that will turn on our lights. So, okay, this fell out because this wire sucks, but we'll just put it back in and screw it back down. Nice. So we have the power source, which is our battery. We have the positive wire going into the common pin in the middle, and then we have the positive wire coming out of the lights into the normally open pin, and then we connect the negative wire on the lights to the negative wire on the battery to complete the circuit. And now let's test it. So to test it, we need to have some power to our Raspberry Pi. Micro USB, turn that on, and you should see a light turn on the relay. That means it's getting power, which is to be expected. And obviously our lights aren't turning on yet, and that's because we have no power going to input 2. So, for example, let's just tie, okay, let's make sure you see the lights here. But since it's normally open pin, unless we have power going to input 2, there's going to be no power going to the lights. Cool, so when we tie input 2 to high by plugging in the input 2 pin, the white wire, into the positive rail on the breadboard, we're able to turn on the lights. And I can flash them. So that means when we actually have the circuit running and we plug in the input 2 wire to the GPIO pin on the Raspberry Pi, by turning on the GPIO pin, we turn on the lights, and by turning off GPIO pin, we turn off the lights. So that's it for this setup video, and then next we'll be going over code, and then we need to do water sensor, and then we can bring it all together and get our hydroponics to work.